The surface of our planet, the ground right beneath your feet, it's not, well, it's not just flat, not by a long shot.
No, definitely not. It's this dynamic canvas, isn't it? Sculpted over millennia into these incredible shapes and structures we see all around us.
That's right. From the, highest peaks defining horizons to the vast sweeping lowlands that feed billions.
Earth's surface is just a constantly changing masterpiece of geology. It really is.
And today, we're taking a deep dive into this stack of sources you've shared with us. We're going to be pulling out the most important nuggets of knowledge, really exploring the major landforms that shape our world.
Exactly. We're zeroing in on the big ones highlighted in your material. Mountains, plateaus, valleys, and plains. We'll look at how these, well, dramatic features were forged.
And crucially, why they play such vital roles for the planet and, for us.
Right.
So our mission in this deep dive is basically to help you see these foundational geographic features through the lens of these sources and really get a grasp on their immense impact.
Get ready to look at the ground beneath your feet and the landscapes beyond in maybe a whole new way.
Okay, let's jump right in then. Your sources make it pretty clear that the Earth's surface isn't static at all. It's continuously being shaped by these really powerful natural forces.
Absolutely. The material you provided really emphasizes the key sculptures. You've got the immense power of tectonic plate movement, the collision, separation, uplift of the Earth's crust.
Yeah, that's huge. And then there's erosion, right? The relentless wearing away of rock and soil.
By wind, water, ice, it just keeps going.
And deposit, that's kind of the flip side.
Yeah.
Where all that eroded stuff, the sediments get carried and dropped off, building up new land.
Exactly. And a volcanic activity, too. Can't forget that. Adding new material right onto the surface.
So it's these fundamental forces working over these vast stretches of time that create this incredible diversity of landforms we see, from the really tiny to the truly massive.
But today, following your sources, we're focusing on those four major types you mentioned.
Right. Let's start with the most dramatic, Earth's true skyscrapers, mountains.
Okay, the sources describe mountains as, well, high points, generally over 600 meters, or about 1970 feet above the land around them. They're characterized by steep sides and distinct peaks or summits.
And how they're built, according to your sources, it's fascinating. A primary method, especially for the really big ranges like the Himalayas and the Appalachians that were mentioned,
is tectonic plate collision. The land literally gets pushed up in folds, kind of like a rug.
Yeah, exactly like a rug, creating these fold mountains.
Right, but you also get block mountains like the Sierra Nevada example in the sources where blocks of land are lifted up along faults.
Okay.
And volcanic mountains, obviously built up by lava and ash. Though the sources do note that even if a mountain like Everest might have some volcanic origins way back, the main process for major ranges is often that folding action.
And dome mountains, that's another one.
Yeah, where underground magma pushes the surface up into a dome shape but doesn't quite break through, like the Black Hills example.
Now, when you think tallest mountain, Everest immediately springs to mind, right? In the Himalayas.
Usually.
Your sources give slightly varying heights, but around 29,035 to 29,320 feet, or 8,848 meters,
Right.
making it the tallest on land.
But that on land part is key. Here's one of those great nuggets from the sources if you measure from the base to the peak.
Where's this going?
The tallest mountain in the world is actually Mauna Kea in Hawaii.
No way!
Yeah, it's a dormant volcano. It rises over 33,400 feet from its base, way down on the ocean floor.
Wow. That difference in measurement, starting point, it completely changes the perspective.
It really does.
And you find these mountain ranges, these long chains of peaks, basically everywhere. The sources mention the Himalayas in Asia, holding most of the world's highest.
Yeah, 14 of the tallest are there.
The Rockies stretching for over 1,000 kilometers in North America, the Andes in South America, plus ranges in Wales, Scotland, China, France, Russia, South Africa. They're genuinely global features.
Totally. But what the sources really hammer home is why mountains are so important. They're often called the water towers of the world, and for good reason.
Right, they supply something like 60 to 80% of the planet's fresh water.
Exactly. That meltwater feeding rivers is just an essential source of clean water for huge areas downstream. It's vital.
And they're massive influencers of climate and weather, too, acting as barriers that can steer storms, create rain shadows.
Yeah, dramatically affecting the ecosystems on either side. Completely different environments.
And biodiversity. About a quarter of all terrestrial biodiversity is found in mountain regions. Lots of unique species that only live there.
Plus, they provide resources like minerals and forests, supporting industries like mining, forestry, hydropower.
Economically and culturally, too, they're significant. Big destinations for tourism, recreation,
Places of spiritual importance for many cultures.
and they often serve as natural boundaries between regions or countries. But the sources also flag their vulnerability, don't they? Especially to climate change affecting glaciers.
Yes, that's a major concern. Glacier retreat, landslides, they're sensitive ecosystems.
Speaking of surprising things from your sources, some experts apparently theorize that earthquakes might actually limit how tall mountains can get.
Yeah, suggesting Everest could theoretically be even taller if it weren't for seismic activity. It's a wild thought.
And those mountain goats, they're not actually goats.
Nope, they're technically antelopes. And they can jump like 12 feet. Incredible animals.
Wow. And mountains aren't just an Earth thing. The sources mention Mons Huygens on the moon.
And on Mars, the absolute monster, Olympus Mons, nearly 3 times the height of Everest.
3 times. And the tallest known in the whole solar system, its crater is like 45 miles wide.
Something like that, yeah. And then there's Venus with mountains possibly topped with metal. It's just amazing stuff.
Okay, so from the highest peaks, your sources then talk about how uplift and other forces can create these vast, flat, but elevated areas, which brings us to plateaus.
Right, plateaus. Described basically as elevated flatlands, kind of like giant tables, often with at least one steep side and escarpment.
How do they form? Seems like a few ways according to the material.
Yeah, several possibilities. Volcanic activity is one, layers of lava spreading out over huge areas and cooling flat.
Okay.
Tectonic uplift is another, a slow lifting of a large, generally flat region without much folding, or even extensive erosion. If you have softer rock surrounding a large area of harder rock, the surroundings can erode away, leaving the harder, flat top elevated.
Interesting. And the sources highlight different types.
You've got huge intercontinental ones like the Tibetan Plateau, just massive.
Right.
Piedmont plateaus found at the base of mountains. Volcanic plateaus formed by those lava flows we mentioned, like the Columbia Plateau here in North America or the Deccan Plateau in India.
Oh, okay, Deccan, Columbia.
Yeah.
And dissected plateaus.
Yeah, that's where rivers have carved deep valleys over time, cutting into the plateau surface. Creates really dramatic landscapes, like the Grand Canyon, which is actually within the Colorado Plateau.
Ah, I see. So the plateau was there first, then the canyon was carved.
Exactly. And there are also intermontane plateaus, which sit between mountain ranges, like the Bolivian Altiplano.
That Tibetan plateau example seems pretty significant. The sources call it the roof of the world.
It really is. Highest and largest plateau, averaging over 4,500 meters, covering 2.5 million square kilometers. It's so immense, the sources point out, that it actually influences weather patterns really far away, like the Asian monsoon.
Wow. Other key examples mentioned were the Colorado Plateau, obviously, the Deccan Plateau, Columbia Plateau.
Even the Salar de Uyuni salt flats in Bolivia are technically on a plateau.
So why do plateaus matter? What's their importance?
Well, your sources note they're often rich in minerals, sometimes actually more accessible than minerals locked up in mountains.
Okay, mineral storehouses.
And like mountains, they can collect water rainfall, snowmelt feeding rivers that supply lowland areas.
Their varied altitudes can support diverse ecosystems too, right? Unique species.
Definitely. The sources mention things like snow leopards adapting to those high-altitude environments.
And depending on their composition and climate, some are important for agriculture or grazing.
Yes, especially volcanic plateaus, which can have fertile soil, and vast grassland plateaus support extensive livestock grazing, like you see with the high-altitude herding on the Tibetan Plateau.
Climate influence again, too.
They can block moisture-carrying winds, creating rain shadows in arid regions on their leeward side. And their unique geology, like those striking hexagonal basalt columns of the Giant's Causeway in Northern Ireland formed by volcanic activity, makes them tourist draws.
And the sources mention plateaus even exist under the oceans, oceanic plateaus.
Yeah, formed either by chunks of continental crust or large outflows of igneous rock on the ocean floor. It really shows how varied these elevated flatlands can be.
Okay, so we've looked at the highest points, mountains, and these elevated flats, plateaus. What about the spaces between them, the low-lying areas? That brings us to valleys.
Valleys, right. Essentially elongated depressions, low-lying areas usually found between hills or mountains. Often, but not always, with a river or stream running through them.
And their main sculptors, according to your sources, are erosion mostly by water and ice.
Exactly. Rivers are the big one, carving out V-shaped valleys over long periods. The Grand Canyon is a massive example of a river valley. The Nile River Valley, too.
Famous cradles of civilization.
Absolutely. And then you have glaciers. Their immense grinding power creates those distinctive U-shaped valleys. Yosemite Valley in California is a classic example mentioned.
You see those U-shapes in higher mountain ranges, right, where glaciers were or still are.
Precisely. But tectonic activity also forms valleys. Rift valleys, like the East African Rift, happen where tectonic plates pull apart and the land between them sinks down.
Okay, different from rivers or glaciers carving them.
Right. And other tectonic valleys can form when large blocks of land move down along faults. There are also box valleys mentioned, with steep walls and flat bottoms, often where harder rock layers resist erosion more than the valley floor.
The sources really stress how important valleys have been historically. You mentioned cradles of civilization.
Yeah, because they often had everything early settlements needed: fertile soils from river deposits, a reliable water source, and a somewhat sheltered environment. The Nile River Valley supporting ancient Egypt is the prime example given.
And they're still vital agricultural hubs today.
Hugely important, often among the most productive areas because of those nutrient-rich alluvial soils and water access. They also serve as crucial biodiversity corridors, sort of natural highways for wildlife.
And their relatively flat floors make them ideal for transportation routes. Yeah, roads, railways, cities.
Definitely. Facilitating trade, communication, population growth, they're often economic centers.
That Sydney Harbor example from the sources is interesting, a valley that actually sunk below sea level.
Yeah, forming a Juria or drowned river valley, which creates a fantastic natural harbor. Valleys can also offer milder weather than surrounding highlands, but the downside is they can be prone to flooding.
Right. And the sources distinguish between gorges and canyons.
Generally, yeah. Gorges tend to be narrower and steeper-sided, while canyons are typically deeper and wider. But the key thing is valleys in some form are found on every single continent.
Okay. Spreading out from the valleys, often at lower elevations, your sources describe these vast, expansive, relatively flat areas, the plains.
Plains, basically wide, flat, or maybe gently rolling areas of land with minimal changes in elevation.
And they cover a huge amount of the planet, don't they? Something like a third of Earth's land surface.
Yeah, about a third according to the sources. It's a stark contrast to mountains covering only about 5%. Plains are really where a large chunk of the global population lives.
How do they form? Seems like several processes mentioned in your material.
Often by the deposition of sediments. Material brought in by rivers builds alluvial plains. Glaciers leave behind glacial till plains. Sediments settling in lakes form lacustrine plains.
Okay, deposition is key.
It often is. But erosion can also level landscapes into plains over long timescales. The filling in of ancient seas or large lakes can create them too. And sometimes widespread lava flows can cool to form vast, flat lava plains.
The sources break them down into types as well. Coastal plains along shorelines, like the Atlantic coastal plain.
Formed by sediment accumulation, often from rivers emptying into the sea.
Interior plains, like the Great Plains in North America, found deep within continents.
Often formed by layers of sediment building up over time.
And floodplains are really important, right? Around rivers.
Absolutely. Areas prone to flooding, where the river overflows and deposits incredibly fertile silt, makes them highly productive agricultural land, like the Mississippi River floodplain example.
Then you mentioned glacial plains, leveled by ice sheets.
It's like in the northern central U.S. Lava plains from cooled lava flows, like parts of Iceland or the Deccan Plateau in India, which has plateau and plain features, and lacustrine plains, those former lake beds that become fertile farmland when they dry out.
Your sources really hammer home the importance of plains, calling them the breadbaskets of the world.
They really are the most crucial agricultural regions globally. That flatness, the deep fertile soils, the suitability for mechanized farming. It all adds up. A huge amount of our food originates in these plain regions.
Yeah, because it's just easier to build on flat land.
They become major population centers, home to large cities, extensive infrastructure roads, railways, and major industries. Easier to develop.
Ecologically, they're significant too, supporting vast biomes like grasslands, prairies, savannas, but also tundra and deserts, depending on the climate, all crucial for biodiversity and ecosystem services.
And they often hold valuable resources beneath the surface, like minerals and fossil fuels. Historically, as you'd expect, their accessibility and productivity meant many great civilizations originated and thrived on or near plains.
It's interesting, too, that plains aren't just an Earth thing either. The sources mention Mars has them, called Planitia.
Right, like Hellas Planitia. And historically, Earth's plains supported massive wildlife migrations, like the iconic bison on the Great Plains.
Okay, so to sort of bring it all together.
Yeah.
These four major landforms, mountains, plateaus, valleys, and plains, they're really the fundamental structures built by Earth's internal and external forces that define its surface.
Exactly. And the sources make it clear they aren't isolated features. They're deeply interconnected. Water flows down from mountains and plateaus, carving valleys, spreading across plains.
Climate is profoundly shaped by the height and position of mountains and plateaus.
The erosion of highlands provides the sediments that build up the lowlands. It's all linked.
So if we connect this to the bigger picture, their combined influence is just immense.
Totally. They determine where people can live, the availability of essential resources like fresh water and fertile soil, regional and even global weather patterns. They shape the very ecosystems that all life depends on.
They have literally guided the course of human history, where civilizations rose, where people farmed, where cities were built, how people traveled.
Which really raises the question for you, the listener. Why does understanding all this matter?
Well, because these landforms directly impact the food you eat, the water you drink, maybe even the air you breathe via climate patterns, and the fundamental possibilities of life and settlement across the globe.
Appreciating them is really appreciating the fundamental, powerful geology beneath our feet and its profound impact on absolutely everything.
So we've journeyed from the highest peaks, across those vast elevated flats, down into the carved depressions, and over the expansive lowlands.
Each of these landforms, mountains, plateaus, valleys, plains, shaped by these ancient and ongoing forces, has its own unique characteristics.
And plays these vital, interconnected roles on our planet. It's quite a system.
And recognizing their importance, which is really highlighted well in your sources, it underscores why their preservation and sustainable management are just so crucial for the health of our environment and, well, for future generations.
So maybe a final thought to leave you with. Consider how these powerful natural forces are still shaping our world today, sometimes dramatically, with earthquakes or volcanoes.
And sometimes so slowly over millions of years through erosion and uplift that we barely notice in a human lifetime.
Next time you see a mountain range off in the distance, or drive across a vast, flat field, or even just notice a river cutting through the land on a map, let me pause for a moment.
Yeah, think about the incredible geological processes that created that feature and how that one part connects to the entire dynamic, diverse, and truly amazing landscape of our planet Earth.